Hello guys, so today we are here to solve this problem called minimum remove to make valid parenthesis. In this problem, we have to do a minimum remove, okay? And this minimum remove is done in order to make the parenthesis combination valid. Okay, so let's go into more detail of this problem. We are given a string S of opening parenthesis, closing parenthesis, and lowercase English letters. So only three things are allowed in this string. Apart from these three things, there is nothing else. Okay, and what is these three things? That ith character of the given string is either opening parenthesis, closing parenthesis, or lowercase English letter. So with this, we will, uh, have this in, there is no doubt, if any character is given, then it is going to be either lowercase English character, or it could be closing parenthesis, or it could be opening parenthesis. So the domain of the, objects which are allowed in this string comes from these three things. Either it is in lowercase English character, or it is opening parenthesis, or closing parenthesis. Apart from these three things, there is nothing else. So with this, we will try to, go ahead and, you know, solve these problems. But before solving this problem, we have to understand what this problem is asking. So now, given this string, our task is to remove the minimum number of parentheses, opening or closing, in any position, so that the resulting parenthesis string is valid and return any valid string. Okay. So there could be many valid strings, but we have to return any of them. So that's good. So we have to, go through the string and check if the opening parenthesis matches with the, closing parenthesis. Okay. So I meant to say opening parenthesis and closing parenthesis match. And that's how we have to, keep on, creating this string. And when the valid string is created, we have to return that string. So we have to ignore certain parentheses, and we have to, include certain other parentheses, so that, we get in the end a valid combination of parentheses. So every opening parenthesis should be matched by the closing parenthesis. So if that is there, that is the case with the given string, then that string is valid string. Anyway, so we'll go ahead and read further into this problem. So formally, a parenthesis string is valid if and only if it is the empty string. So empty string is valid in all cases. Containing only lowercase letters, characters, or it can be written as AB. Okay. So this is, recursively it is trying to define what is the, valid parenthesis. So it can be written AB, A concatenated with B, where A and B are valid strings, or it can be written as, opening parenthesis A and then closing parenthesis, where A is a valid string. So now we will try to go through this problem, and in this problem, we will solve this problem. So char array SARR is equal to S dot to char array. Okay, like this. So this will give us the, uh, things which are there in this. Okay, so already we have created this char array, and then what we are going to do, we have created this thing, and then at the end we have to do string builder. So this solution, we are going to create one string builder, and in this string builder we will be, depending on the situation of the problem, we will be creating this, when parent is equal to 0, close parent is equal to 0. Okay, perfect. So now we will solve this problem. So for and I is equal to 0, I less than n plus plus I, if SARR of I equals is not equal. So if it is lowercase English characters, we are not bothered. So how to do that? Either this, and SARR I is not equal to, then in that case, in the, we will append this SARR of I. Okay. Otherwise, if SARR of I is equal to plus plus open paren plus plus open paren and in this case we will plus plus close paren. Okay, so this is there, and what we are going to do, that if open paren is greater than equal to close paren, so then we are going to sb dot append SARR of I. So see, uh, now we are only appending. Okay, okay, okay. So, this, in this first scenario, if the lowercase letters are there, then we are just appending it into the resulting string builder, and moving to the next iteration of the loop. We are only coming to line number 12, 13, and 14 if the character under consideration is either opening parenthesis or closing parenthesis. And in line number 14, we are making again append based on the condition that this opening parenthesis is greater than equal to closing parenthesis. So we are making sure that any closing parenthesis which is coming to us, if we are encountering any closing parenthesis without even meeting an opening parenthesis, so we should discard that closing parenthesis. So to do that, what we have done it like this. Okay. And in else part, we will, to discard that, we will, since we have already taken, this count of closing parenthesis, incremented the count of closing parenthesis, and we have ignored this closing parenthesis because this closing parenthesis is coming before any opening parenthesis. So in that case, we are, ignoring this, and since we have incremented this closing parenthesis count, so we are decrementing it. And after doing this, what we are going to do, so we have come to this point. Okay. At this point, after the end of this for loop, what will happen, that the closing parenthesis will be matched by an opening parenthesis. But if there are any extra opening parentheses which are not matched by an, closing parenthesis, so that we have to remove. To remove that, what we will do, that, we will again create, this, let's say int I is equal to sb dot length -1, like this, and then opening paren is greater than closing paren, and I is greater than equal to 0. So if there is any character in this, and then if SARR SB dot char at I is equal to SB dot char at I is equal to this thing, opening parenthesis, then we are doing SB dot delete char at of I, and then what we are doing, we are decrementing this open parent count after doing this, what we will do that we will decrement our I value. And then at the end, we will do sb dot to string like this. Okay. And after doing this, we will run this solution. Perfect. 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 God is great. So see, this solution is, beating many other solutions in terms of efficiency, in terms of time efficiency, time complexity. And though this is having two pass, but this is, you know, this is uh, this, uh, it cannot be, it can be done, but in a simple, straightforward way, which we have adopted over here, this is the most simplest solution that, I can think of. If you are able to come up with even simpler solution, please post it in the comments. With this, I would like to close, end this video. If you are, not able to understand something, please post it in the comments and I'll try to answer them. But once again, I would like to go through the solution. So in this solution, first of all, we are taking this input string and then converting it into an character array. And after converting it into a character array, we are taking the, length of this. So instead of doing this length of this, we can have, directly taken length of this. So this is simpler. And then we are declaring opening parenthesis count and closing parenthesis count. We have initialized them with 0, as is obvious, which is correct. A string builder we have taken because we are constructing the solution. We are constructing the solution so that we are only including those parentheses which are, which are going to be valid, and which are going to meet the criteria. And what criteria do we have? So the criteria that we are having, that if the given character is not an opening parenthesis or closing parenthesis, then our validity of the string is not going to be affected by that, and we are just appending it and continuing with our solution. After this, what we are doing, that at line number 12, we are, counting if we are encountering any, opening parenthesis, then we are incrementing this opening parenthesis count. If we encounter any closing parenthesis, then we are, you know, um, updating the count of closing parenthesis. And at line number 14, when we come across this line number 14, what we are doing, that we are checking that if open parenthesis is greater than equal to closing parenthesis. So if open parenthesis count is greater than closing parenthesis, it means that wherever the, closing parenthesis is, it is there with, for which we have this corresponding opening parenthesis. Okay. So wherever this opening parenthesis is there, we have, uh, this closing parenthesis is there. Okay. But if we encounter a situation where closing parenthesis comes before any opening parenthesis, then in that case, we are not appending it to the string builder. We are just, skipping that append part and decrementing the closing parenthesis count because we have ignored that. So this minus minus we are doing because we have ignored that, closing parenthesis. We have effectively ignored that closing parenthesis count. Okay. So with this, I hope this is clear. And then once we come to the line number 20, the situation in our string builder is that, we have more number of opening parentheses than the closing parentheses. Okay. So we have both the counts, and we again start from the end and take a look. If we have opening parenthesis, then we delete that and decrement the count of opening parenthesis. Okay. And this we do till the opening parenthesis count is more than closing parenthesis count, or there are characters in the string builder. So we keep on doing this, and at the end, we take this string builder and convert it into a string and return that. So this is what we have done in this solution. I hope this is clear to everyone. If there is any further doubt, please post it in the comments and I'll definitely try to answer that. With this, I thank each and every one of you for your patronage. Thanks a lot.